Lesson 9.5, Day 2. Your class left off in the middle of problem C, correct? And if you recall yesterday, we were talking about geometric series. Geometric means we are multiplying by that same number to get to the next term. Series means we're adding all these terms together. Let's see, in this problem, I had compared this problem to the explicit form, if you recall. And so I had talked about that your A1 is often that term out front. The number being raised to the power is always the R. And then in this case, N was 21. And N was 21 because from 0 to 20 is 21 numbers, right? I talked about the fact that you guys know 1 to 20 would be 20 numbers. So if I add 0 in there, that's the 21st value. Okay, so we are ready to set up our formula? So our formula we are using, S of n equals A1 times 1 minus R to the n over 1 minus R. Nothing fancy there, I just wrote the formula down that we're using. Do you know all of that information to fill in? You should, right? So S of n, we're finding the sum of what? Sum of 21 terms, right? And then on top, A of 1 was 4. 1 minus R to the n. So that's going to be 1/2 raised to the n. Oh, and what is n? 21. I just kind of forgot. We know n, don't we? I get so used to not knowing n. All divided by 1 minus R, which is 1 minus 1/2. Okay, thoughts on this problem from here on out? He's going to put in his calculator. Okay, officially 1/2 to the 21st, yes? Now, what's probably easiest to do on your calculator here? Instead of 1/2, 0.5, yes? And this is one, you know, I'm your math teacher. I always try and encourage you to use fractions as much as we can, but are we doing 1/2 to the 21st by hand? No, not a chance, okay? We're not doing it. And so, you know, the fact that we're using calculators here, I would fully support. Let's take that 1/2, forget 1/2 and use 0.5 because that's much easier to enter in my calculator. So if you instead would rather have written this out as 1 minus 0.5 to the 21st divided by, what is 1 minus 1/2 or 1 minus 0.5 and on bottom? What is 1 minus 1/2? 1/2 or 0.5? Okay. Oops. So, you know, grab your calculator. Officially, it's the 0.5 to the 21st. Most of you, you would be best off going ahead and doing 1 minus 0.5 to the 21st. Using your parentheses, you could even do 4 times 1 minus 0.5. You know, again, I can enter this whole thing on my calculator as is, but you have to have confidence in how to use your calculator. Okay. So, options. I can start my parentheses. 1 minus 0.5 raised to the 21st. My calculator knows to do my exponent and then subtract. There's inside the parentheses. That's yuck. Okay. Should I round that? Not necessarily. Okay, my recommendation is leave this on the calculator and do what next? Multiply by 4, so I'm just going to hit times 4. Okay, then what? Divide by a half, right? So divide by 0.5. Now, all that time later, what do we know? Okay. Not S of 10, S of... Okay. Okay, I wasn't sure what you said there. I was like, that wasn't 21. Okay, S of 21, which is approximately what? Can we round it now? I mean, at this point, if you go 1, 2, 3, 4, 5, you're going to have to go to the 6th decimal place before you can not round all those numbers. Okay, so yeah, this is the point where we're going to round it, and we're going to say that this is approximately 8.
I have a question.
Yes?
You know when a calculator does this?
No.
So when I do it with the decimal, it's an not. When I do it with that, it's an not. So it's like
That's my opinion usually.
So
My graphic calculator does
supposed
that.
to be right, or would you want me to reduce that?
I don't want you to give me that crap because you have no idea what that crap is.
I've got the 7.9999.
Oh, okay. See there, that's how you do that.
So you want me to just reduce that?
Yeah. And what you could do on this calculator is take and type in top number divided by bottom number. There should be a way to change that to a decimal.
That probably is.
Figure it out.
What do I think?
Okay. Okay. D.
But that's
Have you started D? The sum from 1 to 10 of 5 times negative 2 to the n minus 1. Okay. You need to identify some information. I need A1, I need R, and I need N. Can you tell me any of that information? Okay. Okay. So, let me talk real quick about this. N is 10. It is 10 because 1 through 10 is 10 digits, right? Now, notice, because n is 1, my exponent is back to being an n minus 1. Because this is n minus 1, we right here are looking directly at A of 1 and R. Okay, we are looking directly at those. Whoops, I made that A2 the first instead of A of 1. Okay, so, and R is whatever is being raised to the exponent. Okay. And again, remember, that is based on the explicit formula of A of n equals A of 1 times R to the n minus 1. Okay. You ready? We'll see, for those of you that are working ahead, if you can get the right answer, if you can do this correctly on your calculators. Again, my formula, S of n equals A of 1 times 1 minus R to the n divided by 1 minus R. What are we trying to find? S of what? 10. Okay, no. A of 1 is 5. 1 minus, what is R? Negative 2. Did you guys notice yesterday when I put that negative in for R, I put it in parentheses? That's important. So it's 1. To be honest, I don't care in the denominator if you use parentheses or not. Where it matters is in the numerator. It is two different things to say. If I type into my calculator 1 minus negative 2 to the 10th and 1 minus parentheses around negative 2 raised to the 10th. My calculator is going to give me two different things. And you have to understand that. Okay, you also have to understand, on top, I cannot say minus a negative is going to be a plus. Because this negative, first and foremost, goes with the power of 10. Okay, so that's the differences you're looking at. So this is why I say it's important you practice with the calculator when we do this in class. Here would be the wrong way to do this. 1 minus negative 2 raised to the 10th. My calculator, well, I don't know. My calculator might or might not do that right. Nope, it didn't do that right. That would be the wrong thing to get. So thus, if I go back and instead say 1 minus parentheses negative 2 raised to the 10th. Notice all I did is I put parentheses around the negative 2. I got a different answer, didn't I? And that matters. Okay? So those parentheses around the negative matter. Then what do I do with this number? Multiply by 5. And then what? Divide by 3. If you're saying, wait, you want me to put that together in my head? Well, if you're refusing, put parentheses around your whole denominator, and it's divided by 1 minus negative 2. And you should be getting negative 1,705. Did you get that answer? Now, does a negative make sense? And this is the thing, you can't really see this, but there's a negative base, right? That negative base, that negative r, remember r is negative, that means every other term is going to be negative, isn't it? And so with every other term being negative, yeah, we could have a negative sum. Negative 1,705. Okay. Are you figuring out how you can and can't use these calculators? Because that's the thing, you have to know what's, I don't know, should I say legal and not legal? Okay. Start working on the word problem. Hello? Yeah. Okay, I will try that later. Thanks. Bye. Okay, have you read the word problem? Number 1 rule, start by reading the word problem. To save money for a vacation, you set aside $100. For each month thereafter, you plan to set aside 10% more than the previous month. How much money will you save in 12 months? Okay. You'll notice the heading. It's using the sum of a finite geometric series. That's the one thing we've learned in this lesson, right? So hopefully you realize we're going to follow suit here. What kind of information can you come up with? A of 1? What's A of 1? First month or whatever, you set aside $100. Okay? Kendra?
R would be 1.1.
Ooh, why is R 1.1?
Because you have to add the
Yeah. Okay, here's the deal. Right now we have $100, right? We're going to set aside 10% more than the previous month. So first of all, we're going to have to know what 10% of this last month is, right? But then, is it just 10% that we're going to be doing? No, because it's going to be 10% of this, which is $10, plus the original amount, and that original $100. So that means each month you're setting back aside, it's 10% more, so 110%. Does it make sense if I say 110%? And when we talk about 110%, and then as a decimal is 1.10. Okay, because you're always doing 10% more than what you did last month. So 110% of last month's amount, which means my R is going to be 1.1. Have I made sense of that? Yes. And then N, we need to know number of terms. How long are we doing this? 12 months, right? We know the first month was 100. The second month, I'll say, is $110. I've done that math in my head. And then each month it's going to be a little bit more because it's going to be 10% more. Don't get too fancy, yes. It's going to get too fancy and too crazy to try and, they didn't specify otherwise, so. Because it does say for each month thereafter. So.
Write all the numbers and have together.
You could.
I love that venture.
You could. Now, me personally, I'm going to use the formula. Because I'm the teacher and that's what I'm supposed to do. And this is one, though, by the time you get all those decimals and everything, or not necessarily decimals, but the numbers, and they're going to get into decimals. To me, the formula is just as easy. I'm trying to find the sum of what? 12? Oh, sorry, I didn't write it. Do you guys still need me to write the formula out? The original blank formula. I mean, I've written it out in the past 4 problems, so let's just fill it in. S of n, so we're doing S of 12, equals A1, which is 100, 1 minus R, which is 1.1, raised to the n, which is 12, divided by 1 minus R, 1 minus 1.1. Okay. You can start with your parentheses. You can get that answer. You can multiply by 100. And then you can divide by 1 minus 1.1. If I want to get fancy, I can enter this all in my calculator at once. 100 parentheses, or times 1 minus 1.1 raised to the 12th in that parentheses. I could go ahead and hit divide. And then if you haven't already done the subtraction, in other words, if it's more than one term, I'm going to put parentheses 1 minus 1.1 in parentheses. Does your final answer match my final answer? Because if your final answer matches my final answer, you did something right with the calculator. I don't know necessarily how you did it, but you did something right with the calculator. Now, how should I express this answer? What is this answer? Money. So how should I express an answer of money?
With a dollar sign.
With a dollar sign and 2 decimal places. So, $2,138.43. If you hit a point where your calculations are not agreeing with my calculations, then whether it be right now during the lesson or whether it be during homework time or whatever, call me over and let me watch what you're entering on the calculator, because I can figure out where you're going wrong on the calculator, or I should be able to at least. Yes?
Oh, no, I will say, like, mine was one penny off because when I added them all together, I rounded when I worked them down. You see what I'm saying?
You rounded them as you went,
right,
as opposed to the formula, which wouldn't be rounding them individually as you go. Right. Okay. You ready to move to the back? what we were working on the front were all finite geometric series. Geometric, you multiply to get to the next term. Series, we're adding. Finite, we talked about finite. What does finite mean? It stops. There is a last term if it's finite. So you're adding a set number of terms. Whether we added 20 terms, 50 terms, there were a set number of terms. The backside. We couldn't do this with our arithmetic ones, but with geometric, we can. We're going to talk about the sum of an infinite geometric series. So a series that keeps going on forever and ever and ever. Okay? Now, here's the deal. We're going to have two types. There is one type where, yes, you can find the sum because those numbers are getting increasingly smaller. And if the numbers are getting increasingly smaller, as you add those increasingly smaller numbers, they're approaching some number. And then we're going to have ones that we can't find the sum because those numbers keep getting bigger and bigger and bigger. And so if there's never any end, it's going to forever keep getting bigger. Okay? So just because it's infinite, I'm not saying we can always find the sum. Okay? So an infinite geometric series with a first term a of 1 and a common ratio that is less than 1. So absolute value of r just means looking at the positive. Okay? Forget negative. Because we all know negative just means my terms are going to alternate positive, negative. But if r is a number that is less than 1, it has a finite sum. Those numbers are getting smaller and smaller, and you can find the sum. So, it's all going to depend on r. If r is less than 1, there is a finite sum. This is called a converging series. Okay? So, if your series converges, there is a sum, and that sum is going to be found using this new formula. It's a lot easier than the first page formula. A of 1 over 1 minus r. However, that was if r is a number less than 1. What if the absolute value of r is a number greater than or equal to 1? Then the sum is infinite. Those numbers are getting increasingly bigger, so you're never going to be able to find the sum. And so this is called a diverging series, because it's not converging on one number, it's diverging. And notice, there's no formula for a diverging series, because you can't find that sum. Okay? So, that's what these examples on the back page focus on. Notice the first question isn't find the sum, it's does the series converge or diverge? You have to answer that question first. Does the series converge or diverge? If it converges, what is the sum? If it diverges, you're just done. Okay? So, look at example A. 1 plus 1/2 plus 1/4. So on and so forth. You've got to know r. I don't even care about A1 right now. All I care about is r. So how do we get from 1 to 1/2 in terms of multiplying? And how do you get from 1/2 to 1/4 in terms of multiplying?
Teacher, pardon the interruption. AP physics students who are taking the exam need to be released for lunch at this time. Thank you.
Okay, so here's what I'm going to say. 1 times something is 1/2. Well, what happens when you multiply something by 1? You get itself, right? So does 1/2 make sense in there? Does 1/2 make sense here? Because 1 times what is 1? 1. 2 times what is 4? 2. Have I convinced you that 1/2 is good? Okay. So what I know right here is to get from the first term to the second term, I multiply by 1/2. To get from second to third, I multiply by 1/2. So we are in agreement that R is 1/2. What do you know about the number 1/2 in relation to 1? Okay, so this falls into the category of the absolute value of R is less than 1, correct? And that's because the absolute value of 1/2 is less than 1, which this is a positive R. Absolute value really doesn't mean anything. But here's the deal. 1/2 is less than 1. Agreed? So, does this series converge or diverge? R is less than 1. My series converges. Am I done? No. If it converges, find the sum. What's the formula I use to find the sum? S is A1 over 1 minus R. Okay, I didn't write A1 down. Please tell me you know A1 at this point in your life. If you want me to be blunt, if you don't know A1, you have been paying no attention for the past 2 weeks of class. Just saying. Okay, A1 is, first term, 1 over 1 minus, what's R? 1/2. This is a lot easier than the last formula, wasn't it? Okay, so 1 divided by, what is 1 minus 1/2? 1/2. 1 divided by 1/2 is 2. And so because these numbers are getting increasingly smaller, this series will converge on the sum of 2. Okay? It is approaching 2. The more and more numbers you add, the closer and closer it gets to 2. Correct.
So when we ever reach to them, is that it's, what's that word?
I have a feeling it's one of those things where we'll round to 2.
Okay.
Technically, it's probably more of a limit, which is more of a pre-calc calculus topic, but yeah, it will approach 2. I don't know that it'll ever wholly equal 2, but it'll get close. If you add just these 3 numbers right here, you're already at 1 3/4. So, okay, B. Okay, we gotta try some summation notation. Now, it's a sum from n equals 0 to what? Infinity, because this is an infinite series, right? This series isn't ending. So of course it's infinite. There is no set number of terms. Okay, but all I really care about is R. What is R? What do you think, Cyrus?
Is it still -5?
Yep. Just like on the front side. Do you kind of see the explicit form happening here? Notice it's n equals 0 and it's n instead of n equals 1 and n minus 1. But, yeah. That is still your R. Which means 2/3 is my A1 most likely. Okay. What do you know? Well, first of all, it's -5/4, right? But remember, we're always doing the absolute value. The absolute value of -5/4 is +5/4. Basically, forget the negative, yes? What do you know about 5/4? Less than 1 or greater than 1? Why is it larger? Why do I know?
Because 5 is bigger than 4.
Yeah, my numerator is bigger than my denominator. This is an improper fraction, so it's bigger than 1. So this is greater than, technically, or equal to. So what do we know if the absolute value of R is greater than or equal to 1? This diverges. Probably your favorite problem of the day. Because, can I find the sum? No, we're done. Okay? These numbers would be increasingly larger. They're not going to be approaching some total sum. It's just not possible.
Would we ever have to find n instead of infinity?
No, there is no n.
You guys just add up the
Because n is the number of terms, and if this is infinite, there is no number of terms. Okay, see? 1/2 plus 3/4 plus 9/8, so on and so forth. Forcing you guys to work with fractions today. Gotta love it.
I don't.
Oh, come on. Now, it's fractions, guys, right? How do we multiply fractions? Straight across, right? So here's my thought. Forget that these are fractions for a moment. Okay? What are my numbers on top? 1, 3, 9. What do you do to get from 1 to 3 and 3 to 9? Can we agree that that is times 3? Okay, that's not horrible, right? Okay, now, forget the numerators for a moment. Think denominators. How do I get from 2 to 4 and 4 to 8? Times 2. So, what is R? I'd say 3/2. 3/2, 3 seconds. They're not wrong, but I would say 3/2. Do you see how I got that 3/2 though? I don't want that to be the hardest part. And I'm not going to say every problem is that easy, but don't stress about, oh my gosh, there's fractions. I'm never going to figure that out. Yes, you can. You definitely can. Okay, what do we know about 3/2? It's bigger than 1. My numerator is bigger than my denominator. It is bigger than 1. So what do we know about this series? It diverges.
I like this one.
You like this problem, Tip? I figured as much. Okay, D. 1/3 minus 1/9 plus 1/27 minus some whatever next term. You can't find a sum if it diverges. I just realized I forgot to write the ones here, didn't I? There we go. Hopefully you guys remember. Okay, so yeah, if it diverges, you can't go any farther. There is no formula. There is no way to do it. Okay. Have you looked at D? Okay, so Dayton I think he was complaining, but I'm going to use this as an example. He says this one has a plus and a minus. What's that mean? We know, whatever we figure out, that the R value is negative. Because it's going plus, minus, plus, minus. Okay? My numerator is all ones. How do you multiply from 1 to 1 to 1? You're multiplying by 1. My denominators, 3, 9, 27. What are we doing with the denominator? Multiplying by 3. So, put it all together. What am I multiplying by? Negative 1/3? Does that make sense?
Yes.
We're multiplying by negative because it's alternating signs. The 1 because it's all ones on top. The 3 because it goes 3, 9, 27 on bottom. So, what do you know about the absolute value of negative 1/3? I mean, the absolute value of negative 1/3 is positive 1/3, yes? What do you know about 1/3? It's what? Less than 1? Right? When your numerator is smaller than your denominator, this is less than 1. If it's less than 1, what do we know about this series? It converges. And what do we know when it converges? Oh, we actually have to do a little more work. Dang it, right? Okay. What was your formula? Okay. A of 1 over 1 minus r. It's the easiest formula we've seen in this lesson by far. What is A of 1? I never stated it, but again, I feel like that ship has sailed and you should know that. S is the first term, 1/3. So 1/3 over 1 minus r, which is negative 1/3. Now, in the denominator, 1 minus negative 1/3. Can I put that minus and negative together here? Yes, because there's no exponent. The reason I was vetoing that earlier is because there's an exponent. I was like, no, we're not doing that. Okay, so we can put it together. I don't know. You guys are all just going to go calculator on me, aren't you? Did you get an answer?
Yeah.
What'd you get?
Negative.
I did not get it.
Should be positive.
I got 1/4.
Yeah, I got one.
That's
Okay. Okay, now, okay, guys, what do you realize about 0.25 and 1/4?
Very close.
If you've got a quarter, you have a fourth of a dollar, yes? 4 quarters and a dollar. So I personally don't care about 0.25 versus 1/4. You know Math Excel might, but I don't. Okay. So whether you say 0.25 or 1/4, I'm content either way. On here, I could do this all on my calculator. Now, first of all, if you guys know how to use the fraction buttons, you could use the fraction buttons, right? But otherwise, on top, whoops, it's 1 divided by 3, isn't it? Divided by, my denominator is 1 minus negative, I think I better do parentheses, 1 divided by 3. Notice I got 0.25, right? Some of you may have tried to go decimals, but 1/3 doesn't really work as a decimal very well. So, again, practice using the calculator, yes? Okay, where are we at on time? I technically have a few more minutes. Let's talk about E real quick. Thoughts on R? What? 2/3? Why would you say it's 2/3? It's the 1 raised to it, and that's exactly what I need to hear. We know that this is the R because it's raised to the power of n. R is going to be raised to the power of n. So R is 2/3. What do you know about 2/3? 2/3 is less than 1 because 2 is smaller than 3, and so that means this series converges, which means we need to find the sum, don't we?
Yeah.
Now, in order to find the sum, we need to know A1.
Yeah, that's what I didn't know.
Okay?
But I should know that.
Is it 1?
So here's the deal. If R is right here, A1 is usually right in front of it. What kind of invisible number could be right in front of it?
1.
And I agree with the 1.
Whoa.
Okay. So, formula of A1, which is 1, over 1 minus 2/3. 2, and I'm not sure.
You accidentally did it wrong.
Yeah, I think you got
Oh, wait.
No.
Nope.
Oh, no.
Nope. Okay. Mistake. Back it up.
Oh, no, you didn't get that.
Okay. A of 1 is not 1.
What's further?
Listen. Here's my reason why. Hear me out. This is n equals 1. Usually if n equals 1,
Oh.
this is n minus 1. But it's not. How can I find A of 1? A of 1 is the first term, yes? So how would I find A of 1? You put in the first n value to the equation. What is 2/3 raised to the first? 2/3. So what is A of 1 actually? 2/3. Teacher mistake. Totally spaced that. Okay? Now, if that had been n equals 0 and n in the exponent, we would have been fine. Or if it had been n equals 1 and n minus 1 in the exponent, we would have been fine. I spaced it. So now, when you start doing this, yeah, because it becomes 2/3 divided by 1/3, which is 2. My apologies there. I goofed. Your homework is lesson 9.5 in Math Excel. Bring your questions back tomorrow.
What are we doing tomorrow?
We will probably start into chapter review tomorrow.
Where's she coming in about?